Hi everybody. Tonight we're going to talk about international standards, which is what this is. We're going to talk about temperature. We're going to throw in a little bit of density, and we're going to talk about some conversion factors, specifically some metric conversion factors that you need to know. So first, we're going to talk about the international standard. This is what the SI stands for. It's actually Système International. It's from France. Okay, and these give you fundamental units. There's 7 of them here. So for length, we measure things in meters. For temperature, we measure things in Kelvin. Now, realize that these are international standards. What we measure them in a lab might be, for example, Celsius. Well, we'll talk about Celsius in just a moment, but Kelvin is what the international standard is. Time is measured in seconds. Kilograms, which we're going to have to talk about in just a second, is the unit for mass. And amount is typically in moles. Now, you don't know what a mole is yet, but you will by the end of this course. So we'll get there. And current is in amperes, and luminous intensities is candelas. We're not going to use these. All right, so I'm not terribly concerned about these. They're there, but we're not going to worry about them. Notice, for example, that length is in meters. Notice there is no prefix in front of meters, nor in Kelvin, nor in seconds, nor in moles. But you do have a prefix in front of grams, and that's often confusing because a lot of students think that the international standard unit for mass is a gram. It is not. It is a kilogram. So this one's a little bit confusing, so you have to make sure that you pick up on that. Make sure you take good notes and write that down. That's something that is an aberration, so you need to write that one down. That's often tested. Hint, hint. All right, so now what we can do is we can derive units from what those 7 are. For example, the unit for length is meters, so we can come up with area, which is meters squared, or meters times meters. For volume, it would be meters cubed. For energy, we have this really crazy thing, which is meters seconds times kilograms divided by seconds squared. But that's energy. And notice all of these units, meters, kilograms, and seconds, are what our base units are in the international standard. Speed is in meters per second. It can be, and acceleration is in meters per second squared. All of these are derived from the international standard. You don't need to memorize those. That's just so that you understand what a derived unit is. And then we have other units. For example, you'll notice Celsius isn't on here because Celsius is actually we're adding or subtracting to get from to get from Kelvin to Celsius. So centimeters, for example, are meters times 100, because there are 100 centimeters in a meter. We can get to inches, we can get to feet, Celsius, Fahrenheit, milliliters, gallons, etc. Notice there wasn't an SI unit for volume. Why is that? Because we can create it from meters. So, all right, so those are just some other units that we tend to use. We often use these, for example. Clearly, you use miles per hour when you're driving. So we use a lot of these. So you should be able to look at units and tell me what things are. For example, if I look at kilograms, what does kilograms measure? Think about it for a moment. Pause the video if you need to think. All right, kilograms measure mass. So you should be able to look at something and say, well, kilograms measure mass. All right. So I'm going to give you a moment. Pause the video if you would, please, and look at all these and identify what dimensions they're measuring, what they're trying to measure, and then turn the video back on. All right. The first one here is minutes, so that's obviously time. 40,000 square feet, that is an acre. That is not, be careful, that is not measuring distance because it's squared, right? Because it's squared, it's measuring area, which kind of leads you to notice the next one, which is cubed, so that is volume. What about mph, miles per hour? Right, well, that's measuring speed, which is distance divided by time. You should be able to look at these and realize just what they are, what they're trying to measure. Milliliters is measuring volume, and meters per second is also measuring distance divided by time. Okay, you should be able to just recognize those. Now, just kind of a refresher on density. Remember that density is often measured in grams per milliliter, and there's a conversion factor that you should be aware of. is that 1 milliliter is the same as 1 cubic centimeter. How big is a cubic centimeter? Well, it's about the size of my little fingernail 3 times. So it goes one this way, and one this way, and one that way. So we have a little box made up of little fingernails, and it's 1 cubic centimeter in size, approximately. And that is 1 milliliter. So what's the density of water? Well, the density of water is 1 gram of water takes up 1 milliliter. So that is the density of water. So if I have something that is more dense than water, it will tend to sink. And something that's less dense than water, it will tend to float. Now, could we measure density in kilograms per cubic meter? Sure we could. It's just different. You have to convert from grams to kilograms and from milliliters to cubic meters, but the concept is the same. So yes, you certainly could measure it in kilograms per cubic meter. How about in pounds per cubic foot? Well, notice it's cubic foot. It's a foot in each direction. So sure, we could do that. Now, we'd be measuring, it's not technically, pounds are weight and mass is different, grams are mass. But the concept is the same, some amount of weight or mass per certain amount of volume. So that would make sense. I'm shifting gears into temperature. Sorry, we got a lot to cover in this podcast and kind of bouncing around, so if you need to take a break and get a drink of water and come back, that's cool. The logic of temperature scales. Fahrenheit. You should know that where water boils and where water freezes. Well, if we think of water freezes at 32 degrees Fahrenheit, and it boils at 212 degrees Fahrenheit. Now, these numbers don't seem to make any sense to us at all. There is a logical reason why they're there, and why they're 32 and 212. But frankly, to me, it doesn't make a lot of sense. I'd rather have a number that was in Celsius, because that number is 0 degrees Celsius, which is real easy to remember, and 100 degrees Celsius for boiling. Wouldn't that imply to you that the Celsius scale is based on water? That kind of makes sense, doesn't it? 0 degrees Celsius, 100 degrees Celsius, that would seem kind of very opportune. Great luck there to hit those numbers. Now, Celsius is definitely based on water freezing and water boiling. And Kelvin is simply another way to do that. In Kelvin, this is 273 Kelvin, and this is 373 Kelvin. And we'll talk about why in just a minute. Okay. But that's just a different measuring scheme. All right, so let's look at temperature. Water boils. You'll notice up here water is boiling at 100 degrees Celsius on the left and 212 degrees Fahrenheit on the right. They're the same. They mean the same thing. We can actually convert between Celsius and Fahrenheit pretty easily. And that same number is 273, not exactly, but pretty close, Kelvin. Now, you'll notice I didn't put a little degree sign up here. I didn't put that little circle up there, right? Because we don't say it's 273 degrees Kelvin. We just say Kelvin. And excuse me, I am wrong. That is 373. The freezing point of water is 273 Kelvin. So I made a mistake. Boiling point is 373, freezing point is 273 Kelvin. So clearly there is a direct relationship between these guys. Look at them. Right? The Celsius went up from 0 to 100, and my Kelvin went from 273 to 373. So they both went up by 100. That's clearly not true in Fahrenheit, where the difference is 180 degrees. So that kind of doesn't make sense. But the other two go along hand in hand. So we do have conversions that we can do between Celsius and Fahrenheit, Celsius, and Kelvin. Now, these guys up here, I'm just telling you what these are. You don't need to memorize them. That's okay. But these down here, for Kelvin and Celsius, you need to know these. You need to know that if I give you a Celsius temperature, you can convert to Kelvin by adding 273. If I give you a Kelvin temperature, you can convert to Celsius by subtracting 273. Now, why do we have Kelvin? I think this has been explained to you before in some other classes, but I'm going to go over it again. We have this thing called absolute zero. The concept of absolute zero is that all motion of molecules stops. This is the coldest possible temperature you can get any substance is absolute zero. And it is negative 273 Celsius. Negative 273 degrees Celsius. So, in other words, if I take negative 273 and I add it to positive 273, I get 0. So the lowest Kelvin temperature, the lowest Kelvin temperature is 0. You may never, ever, 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 ever have a negative Kelvin temperature. If you ever get one, it did something wrong. Okay? So, that's kind of a hint. Big hint. Alright, so let's do some temperature conversions. Well, if we're trying to go from Celsius to Kelvin, remember that Kelvin can never be negative. So if I have a negative Celsius temperature, I have to have a positive Kelvin temperature. So this tells me to go from Celsius over here to Kelvin, I'm going to have to add 273. So if I add 273, I get 288. And hopefully I'm doing my math right. Now, if I'm going from Celsius back to Kelvin, instead of adding 273, I have to subtract 273. So this number would be 25 degrees Celsius. All right, so I'm going to stop there for a minute, and I'm going to let you see if you can do these next 5. Now remember, what you can do is you can go back to the previous page if you need to look at the equations, but these are equations you need to memorize. Go ahead and do these 5 things, then come back, and I will explain them. All right, 37 Celsius, if I take 37 and I add 273 to it, I get 310 Kelvin. This is a very important temperature because if you actually go through the conversion to Fahrenheit, you will find that this is 98.6 degrees Fahrenheit, which is body temperature, normal body temperature. All right, so what's 200 Kelvin? Well, if I subtract 273 to go to Celsius, this is going to be negative 73 degrees Celsius. If I go from 150 Celsius, that's very hot, and I'm adding 273 to come over here to Kelvin, I'm going to have 423 Kelvin. If I have 373 and I'm going to Celsius, that's 100 degrees Celsius because I'm subtracting 273. And to go from Celsius to Kelvin, I have to add 273, so 0 degrees Celsius is 273 Kelvin. All right, so that's it for temperature conversions. You should be able to do those. And now we get into metric prefixes. I'd pause the video and write all these down. And you might not want to put them next to each other because I'm going to put some other information next to them in just a moment. Okay, so pause the video, write them down, or wait till the next page, either way. All right, so here's the next page, and these are things that you should already understand. Now, when you look at something like, let's take milli, for example. That's 10 to the minus 3, right? Another way to write that is 1 over 1,000, or 1 over 10 to the third. That works too, right? Now, for me, what I do is I think of this a particular way. I think of millimeters. I think of centimeters. Let's think of centimeters for a moment. And you should realize that there are 100 centimeters. 100 centimeters is equal to 1 meter. Well, and centi is 1 over 100. So that's where the 100 comes from. So I don't think of centi as being a hundredth. I think of centi as meaning there are 100 small things, centimeters, in 1 meter, which means there would be 1,000 millimeters in 1 meter. That also means there would be 10 decimeters. And I honestly don't know what the abbreviation is for that in 1 meter. Right? How about micrometers? Well, I went from 10 to the third. Notice there are 3 zeros out here. 10 to the third to 10 to the minus 6th. So that would be, I'm going to have 6 zeros. 1, 2, 3. So to me, there are 1 million micrometers in 1 meter. Well, now we go to 10 to the minus 9th. That would mean there are 1 billion nanometers in 1 meter. And there would now be a trillion, sorry, my fault, picometers in 1 meter. So that tells you that picometers are really, 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 really small. Okay, that's what you're trying to get out of this. And there's so many, there are a trillion of them in a meter. Well, how about the other prefixes that we just saw a moment ago? The other prefixes were big numbers. Well, which ones do you know? Well, you certainly should know kilo. And kilo means 1,000 or 10 to the third. So that tells you that there are 1,000 meters in 1 kilometer. Let's go back and look and see what we just did previously. You'll notice that we had all of these things were in 1 meter because they're all smaller than a meter. Now what we're going to do is everything is bigger than a meter. So now we're going to say there are 1,000 meters in 1 kilometer. Mega you should recognize. Think of Mega Millions, the Mega Millions jackpot, the lottery in Virginia. And there are 1 million meters in 1 megameter. Well, that would lead you to believe that there would be 1 giga, be 1 billion meters. By the way, let's just do this. Let's just change it to liters in 1 gigaliter. Notice it doesn't matter whether I'm talking about meters or grams. I could use this one for grams, so I could say there are 1 trillion grams is equal to 1 teragram. Similarly down here, notice it's 10 to the 2, that's 2 zeros. That's 100 meters in 1 hectometer. Down here there are 10, let's say grams in 1 decagram. I don't care whether you look at it as 10 to the third, 10 to the 6th, 10 to the minus 6th. If that works for you, cool. Keep doing it. For me, this is the way I think of it, and I'm going to be explaining dimensional analysis in the next podcast using these conversion factors. Okay, so these conversion factors are things you need to know. Make sure you write them down. Right, they're all in your packet as well. Okay, so the summary here is SI units, derived units. You should be able to determine when you look at something and it says cubic feet, you should realize that's volume. We did temperature conversions, specifically between Celsius and Kelvin. We do not need to worry about Fahrenheit. And I showed you a bunch of metric prefixes, which we're going to use in our next podcast. Make sure you wrote those down. Okay? We'll see you in class. Have a good one.